and gentlemen. Today I will be doing the Unit 7 review, which focuses primarily on radicals, and pretty much all there is to know about radicals except for graphing radicals. That will actually be kind of in the next section. So today we'll be simplifying radicals, whether that be square roots, cube roots, fourth roots. Then we will also be multiplying, adding, rationalizing denominators, and also multiplying by conjugates, and so forth and so on. Oh, and also solving radicals to kind of give you a summary there. Okay, so up first, the very top section here says, simplify each radical expression using absolute values when needed. So, first off, you should look at the first example and say, always start with the numbers, in my opinion, because numbers are very easy. So think to yourself, I have the square root of 900. First of all, I will recommend that no matter what, anytime you are given a number, always check it in the calculator first, especially if you're allowed a calculator. If not, you're going to need to kind of know these. But if I go ahead and pull up a calculator here, I want the square root of 900, right? So here's the square root button, so I'm going to go ahead and click that, and you'll see it changes to a 30. That means that the square root of 900 is straight up 30, okay? So nothing really fancy goes on here, it just becomes 30. Now I do want to remind you that when it changes into a 30, it is no longer in the house. So frequently I see people make this mistake and they'll say the square root of 4 equals the square root of 2. That is not the case, okay? The square root of 4 is simply a 2, and therefore the house is gone. So kind of keep that in mind, especially when you're working with a nice pretty number like 30. Then you get into this a to the 4th, b to the 6th. Right, and let's think of that as a separate category than the 900. So the A4 says that I have 4 A's, right? The B6 says I have 6 B's. Okay, this is a square root. Technically the 2 is not present there, but it is technically there, henceforth the name square root, which means I need groups of 2 in order to pull them out of the house. And a little background information in case your teacher may not have explained this, or, you know, however the case be. But really what happens that the square root of 4 becomes 2 is because that square root of 4 can become a 2 times 2. Here's a pair of 2's. That means I pull that 2 out of it. Okay? So that's really what's happening here is every time you locate a pair, one of them kind of they come out together, but only one is visible. So, you know, another example, square root of 16. That can be rewritten as the square root of 4 times 4. Well, 4 and 4 is a pair, which means I'm going to pull it out and be left with 1, 4. So, similar thing with the variables over here. If I want pairs of 2, here's a pair, and here's a pair, which means I'm going to pull out 2 A's. So I'm going to have an A squared. Now, if there's anything left over that didn't have a pair, it would still be in the house, but in this case, there were no A's left over. Let's check the B's. So I have a pair here, a pair here, and a pair here. That means that I have 3 pairs, so I need a B3 on the outside. And again, if there was anything that did not have a pair, it would still be in the house, but nothing here didn't have a pair, so it'd stay there. Now, I'd like to draw your attention back up to this whole absolute values, which for my classes, we haven't really talked about absolute values for a couple of weeks now, so this could be a good refresher as to what does it even mean to have absolute values. So absolute values, we only put our even indexes. Oops, I missed the end. Indexes, right? So anytime your index, that's this little number, or this little number, or this little number, or this little number, anytime that it's even, you should have absolute values pretty much around, you can safely say everything, but in reality, if it's an x squared, no matter what number I plug in there, it's going to come out as positive. If I plug in an x to the third, well then it could be positive or negative, in which case that's where the absolute values are going to kind of come in. So really technically, anytime the index is even, you need to use absolute value on odd exponents. Now, if you just kind of put it around everything, that's fine. So for example, this first one, In theory, it should only be around the b to the third, because that's the only thing that could possibly come out as negative. If you wanted to put it around everything, it's really not the end of the world, because the absolute value of 30 is going to be 30, so it doesn't really matter if it's in there. A squared, even if it's a -1, when I square it, it's going to come out as positive, so it does not have to be in the absolute values. The only thing that has to be in the absolute values is the b, and I would prefer this as the answer. So if you can really try to hone in that skill of just focusing on anything with an even index and an odd exponent needs absolute values. Now in this particular example, this is an odd index, so we don't even need absolute values. You don't even have to think about that. In this case, you're just going to think about what is the square root of -64. It has to be a -4. So no absolute values there, because if you chose a +4, it would come out as +64. It has to be a negative, so absolutely no absolute values. And then same thing as we did over here with the a, the b, and this time we're doing it with the x. You have 12 of them, so think to yourself, how many groups of 3 can you make? You could also just ask yourself, 12 divided by 3 is what? And that's going to give you a 4, in which case that's your answer. Now you may be wondering to yourself, well, what if it doesn't work out perfectly? What if, for instance, instead of a 12, maybe you had an x to the 13th power? Well, you're going to say, well, how close can I get to 12? Well, I can pull 4 out, and that would get me to 12 instead of 13. So when I get to 12, there should be 1 left. He would still be in the house. So let me give you an example of slightly smaller numbers. Let's say that I have x to the 4th under a cube root, right? So I have 4 x's. How many groups of 3 can I make? Well, I can make 1. So that means I'm going to pull 1 x out front, and then this sad little fella didn't have any partners, so he has to stay in the house. And I frequently use an analogy in my class of like saying moving out of your parents' house. If you have a group of 3, you have the funds to move out of your parents' house. So you guys will all move out into one house. So that's why there's only 1 x outside, because all 3 of these people just moved into the same place. They moved out of their parents' house together in one place. This guy didn't have a partner to move out, so he'd have to stay under. Even if this was, let's say, a 5, that means that there's 2 x's that did not have a partner. That means I need an x squared inside, because 2 guys were left inside. So that's kind of how we deal with the variables. The rest of these, very similar. Let's say I go into this one. The only thing is a reminder, some of these you're going to have to break down and say, here's 16 and 2. 16 is a perfect square. Anytime you break anything down like this, one of them has to be a perfect square. So if you were to pick, something like a 3 and a 6, that doesn't give you 32, but 3 and 6, neither of those are perfect squares, so it's not going to help you. But 16 is a perfect square, while 2 would have to stay in. And then the s's and the t's, you could start doing this thing, and that means you're going to have 2 s's on the outside. 1, 2, so I have 2 s's on the outside, and 1 set of t with the 2 still inside. Now I do want to remind you, this is an even index. Remember up here, even indexes. So this is an even index, so I have to go back down here and say, okay, well, if I put absolute values around 4, it's not going to change it. If I put absolute values around s squared, it's still not going to change it. This t, however, could be negative, so I want to go ahead and make sure I have absolute values around that. And then the square root of 2, of course, is always going to turn out positive. Square roots always come out positive, unless, of course, they're cube roots, but that's a different story. I also want to remind you, you're going to have absolute values around number 4. So if you see I broke down number 4 there, you're going to get 3x to the 3rd and y to the 9th. Both of those are odd exponents, so they both need absolute values. So you can actually take a look here. I did this one a little bit different. Instead of trying to write out 12 x's, I said, well, this is a 4th root. And anytime you take a 4th root, you raise it to the power of 1/4. Even with the square roots, you could have raised it to the power of 1/2. Cube roots, you could raise it to the power of 1/3. Either way, anytime you have indexes, it's raising it to a fraction power. And then all I really had to do was take 1/4 times 12, 1/4 times 36 and get that 3 and the 9. But if you like the circle method, that's also a very valid way. It just gets a little hard, especially when you get into 36 of them, but you will be able to manage either way. So in the next section, this section just says simplify each expression, assume all variables are positive. This is a very important aspect, and then if the directions do not say that, you're going to have to think about having those absolute values again. But the second it says assume all variables are positive, you don't have to worry about absolute values anymore. Just do the math, and that's going to be your answer. So the first type of problem here, you're going to have foiling. So when I take 7 times 7, you're going to get 49 plus a 14 root 3 minus a 14 root 3. And then on this last one, it's a little tricky because you have an outside number, which is going to become 4. You're going to have an inside number, which is going to become 9. Now, I do want to point out here that the two middle pieces are going to multiply out. They kind of cancel each other out. That makes this a conjugate. And I'm pretty sure that I spelled that word completely wrong. But you know what I mean, conjugate. Now, this last piece here, I want to say square root of 9 is going to become 3. So now all of a sudden, I'm going to have a negative 4 times 3, which is going to give me a negative 12, which will get me to my final answer of 37. Conjugates we will be using in just a moment down here with number 9, so don't really forget that skill. Conjugates are exactly identical, 7, 7, 2 square root of 3, 2 square root of 3. It's just one is a minus, one is a plus. So kind of keep that in mind. Examples like number 6, I would recommend starting off by bringing them together. So they're in the same house. 3 times 12 will give me 36. X times x to the third will give me x to the fourth. Y and y gives me y squared. And then all of a sudden it becomes very similar to like number 4 or any of the other square root ones, and you can kind of break that down. Okay. Number 7. Number 7 is one you kind of want to break down everything. Now this middle piece doesn't end up breaking down at all, so I would leave it as a negative square root of 5. But 20, you kind of want to break it down. So I will say that with 20, this is where people frequently go wrong. They'll say, oh, well, 2 and 10. However, neither 2 nor 10 are perfect squares. So yeah, sure, you can break it down into a 2 and a 10, but that's not really going to be helpful. So then we say, well, what about 4 and 5? Well, that works because 4 is a perfect square, which will become 2, and then the 5 will become square root of 5. Okay, and I'll let you kind of break down 40. Now, there is something I want to point out. Actually, I'm going to finish out this problem for you. So if we break down 40, that's going to give you plus root 5. And remember, when you're adding, subtracting, you're pretty much just dealing with the front numbers. 2 minus 3 plus 3 gives you 2, and then that square root of 5 just doesn't change and travels 2. Now, a quick reminder that's very similar to if I had a 3a plus 2a would just give you 5a. The a does not change anywhere in the problem. The reminder that I wanted to mention a little bit earlier is in the circumstance, let's say I make up a different example here, and maybe you have a 5 square root of 45, over here instead of this one, maybe at a 5 square root of 45. You would still break this down into a 9 and a 5. That has not changed. The 9 would become 3 and the 5 would stay. But don't forget about bringing down that 5, because now you have a 5 and you have a 3, which will make that 15 on the outside, multiplication, and now all of a sudden you have 15 root 5. So don't forget about if there are any numbers out front, you're going to want to address those and kind of carry them through until you get to that simplified version, 3 root 5, and then go ahead and take that 5 and multiply. Number 8, if you just kind of distribute that, and then you're going to have to break this down a little bit. This one, I will say you get square root of 6 minus 6 root 2. Remember, there's really nothing you can do here. One's a square root of 6, one's a square root of 2. There's nothing you can do that's going to end up being your answer. So one of the key things with radicals is kind of knowing when to stop. Now, rationalizing is kind of my favorite section, although it can prove challenging for many people, especially if you're not studying. But if you're watching this video, hopefully you are studying. Number 9, as I mentioned, this is going to be the conjugate one. So you just want to say what is exactly the same, 1 and a square root of 2. This is a minus, so this is going to be a plus. And of course, the top and bottom get multiplied by the same thing, so I'd kind of write it out twice. On the bottom, you end up foiling, so frequently I just write the word foil underneath because there isn't enough space to kind of do the arches. But if I go ahead and FOIL this, you're going to get a 1 plus a square root of 2 minus a square root of 2, and then minus a square root of 4. The 2's, just like I talked about up top, are going to cancel each other out, and you're going to be left with 1 minus 2, which gives you negative 1. So on the bottom, we have now gotten rid of that radical, and I simply have a negative 1. You are allowed to have negatives on the bottom. That's no problem there. It's just you can't have a house on the bottom. So by multiplying by the conjugate, it kind of gets rid of the house. Now on the top here, don't forget that that 3 is going to end up getting distributed. So 3 times 1 gives you 3. And then 3 times the square root of 2 gives you 3 square root of 2. Now, number 10 and number 11 are somewhat in the same category. It's just one's a fourth root, one's a third root. Frequently, when you're given these types of problems, square roots usually aren't too bad, but the second you get into cube roots and fourth roots, you start wondering, well, what do I have to multiply it by? So frequently, people jump right in and they say, oh, let's multiply it by itself. But if I take 8 times 8, that's going to give me 64. That cannot simplify any. Fourth root of 64 is not going to go away, okay? So, 8's really not going to end up working out here. So then you ask yourself, well, 8 times what gets me to a fourth root? So if you have a little half sheet of paper that I gave to my students, or if you have any type of like cheat sheet with all the lists on them, you should see that the square root of 16, fourth root. The fourth root of 16 becomes 2. So all you really have to say is 8 times 2 gets me to 16, in which case 16 can then just become a whole number. So you're always just kind of asking yourself, 8 times what will get me to one of those fourth roots? Now if I've chosen 2, I'm going to have to multiply the top by that as well, which is where that 12 kind of comes into play. 12 will not simplify. It's not on our yellow piece of paper. It doesn't kind of break down at all. So therefore, it just stays the fourth root of 12. But the focus here is that the bottom is no longer in a house. It's just a simple little 2. Now, I mentioned number 11 is going to be very similar. So you're trying to get that bottom piece to be a cube root. So when I'm thinking of different cube roots, I think to myself, well, I know that there is a cube root of 8. Cube root of 8 is absolutely going to work. It's on my paper. Of course it will work. It'll become a 2. So I'm going to have to take 2 and multiply by 4 to get me to the cube root of 8. Now the variables are a little tricky. So here we have x squared, right? But I'm trying to get it to be an x to the third. So in order to pull anything out of a cube root, cube house, I would need 3 x's. Because if I have 3, that allows me to kind of pull it out then. But in my original problem, I only have 2. Henceforth, I need 1 more in order to get me to an x to the third. Once I have that x to the third, I can cube root that. Cube root of 8 will become 2. Cube root of x to the third will become x. Now, this particular problem has a little added bonus fun involved with it, which is going to break down to be these 2 x's. So you'll see that this is kind of my simplified version, this 2x cube root of 4x over top of 2x. Now, in theory, this would be your answer because you have gotten rid of the house on the bottom. So we've rationalized it, which is exactly what the directions say to do, rationalize. However, this is not fully simplified because 2 divided by 2 would become 1, ends up disappearing. X divided by x also becomes 1 and ends up disappearing. And therefore, my final answer, completely simplified, would have to be the cube root of 4x. So do kind of keep that in mind to always check at the very end, does anything simplify based on exponent rules? Now, on the backside, this is adding to that idea of exponent rules. So you have, I'd like to say, 3.5 rules that you definitely need to know. You need to know if the exponents are the same, if the bases are the same, then we can go ahead and add the exponents. If you have an exponent to another exponent, that's when you multiply. And then the third rule that you need to know is if you divide, you need to subtract. Now I said 3.5 rules, that's because technically the other rule would be negative exponents. So if I have a to the negative 5th, technically that's 1 over a to the positive 5th. Another bonus one, again, these are just all exponent rules, is anything to the 0th power is 1. That's a very popular one to kind of forget. Now this particular one, number 14, is fun because these two things are actually identical. So therefore, I can just keep the inside. We'll call it the base. This whole thing is your base. And then I can just add the exponents. Now in this case, 1/2 plus a negative 1/2 should give you 0. And this rule up here said anything to the 0 power is 1, which makes this whole thing just a 1, which is kind of cool. But all the rest of them, you know, if you're looking up at this one's going to be an adding 1. But I do recommend that when you get 3/4 and you're trying to add to 1/2, you might have to think to yourself, well, how can I rewrite this? So that way they have the same denominator. So now you have 3 plus 2 will give you a 5/4. That becomes your new exponent, 5/4. And then depending on the directions, you might want to put that in radical form. A reminder with radical form while I'm speaking of it is remember that the denominator is always your index, and the top number up here is always your exponent. Now that exponent can be inside or outside, so if I wanted to kind of move that 5 on the outside, it doesn't make a difference. It's still an exponent, and therefore it's the top of my fraction. Some of these other ones, now this one's negative, so you have kind of two options here. You can go ahead and distribute it inward, which is actually what I did on my answer key. If you're taking a look at that, you'll see I kind of took that 1/2 and distributed it. The second option is you can think, well, first of all, it is negative. So let me go ahead and move this piece to the bottom. And now it becomes positive. Sorry, a little quicker there. Now it becomes positive. Once it's positive, think about a house, right? So this is 1/2, which means it's going to be a square root of 9x to the negative 4th y squared. The only thing is you run into a small snag here, especially if you don't know the rules with that whole -4. So that's why I kind of lean more towards the distributing method, because when you distribute, you're going to have that negative times negative giving you positive, and then you won't really have to worry about, oh, what do I do with the negative exponent when it's in the house? This kind of takes care of that if you distribute. Number 11, if you go ahead and take a look at number 11, I went ahead first off and I rewrote it. So I left the negative there, but I took that 4 and I made it a house. And then like I said over here, that 5 can be inside or outside, doesn't really make a difference. So in this particular one, I chose to put it on the outside. That way I could focus on just the 4th root. The 4th root of 81 became 3, and the 4th root of 8, or x to the 8th, becomes 2. And now all of a sudden I just have this -3 that I kind of got to, we'll call it distribute. It's not really distributing, but it's kind of getting applied to everything. So first off, I went ahead and dealt with that negative, put it on the bottom, and then kind of applied it to the 3 and applied it to the x. So really for this section, I would just say try to remember some of your exponent rules, reviewing those. And then the last section in this particular unit will be the solving section. For many of my classes, this is their favorite section because we've actually kind of done math like this before. So, you know, we say there's two options here. You could rewrite this as a fraction exponent, x plus 5 to the 1/3 power equals 6. In which case we talked in class that all you really have to do is raise it to the reciprocal power, which is 3/1. 3/1 is of course the same as 3, and therefore you're left with x plus 5 equals 6 to the 3rd, which is 216. The other option we said is you can pretty much take this original example. It's a cube root, so to undo a cube root, you raise it to a cube power. This one over here is a square root, so to undo it, you'd have to square it. However, this particular one has that -1 outside of the house, and in order to kind of do these rules of raising it to a different power, it does have to be by itself. So I would recommend here getting one on the other side, and then you can go ahead and say, well, it's a square root, henceforth the name, square root. Therefore, the opposite of it is a square. When I square a square root, they kind of cancel each other out, and that leaves you with x plus 5 equals 9. And then to finalize it, you would have to bring the 5 over to give you your final answer of 4. Now, number 17 is given to you in exponent form. So I would just honestly recommend raising it to the reciprocal power. If you don't like that and you want to go ahead and turn that into a cube root first, and then say, oh, well, to undo that, I'm going to cube it, you can do that as well. Either method is fine. They're interchangeable, and they both will work. There's just one final problem that usually proves a little tricky. Actually, before I get into that, I do want to mention something. In number 16, something you may encounter is sometimes there's a number that's out in front, like let's say 4. I would get rid of the 1 first, because the 4 is kind of attached to the front of the house right now, where the 1 you can just kind of add over. But I would say at this point, if there's like a 4 out front here, hypothetically speaking again, make sure you remember to divide by 4 before you start doing this square rooting. You need the house to be completely by itself before you can square it. Okay, so just kind of keep that in mind. But back on track. So number 18 is a special case because you kind of have that square root inside there. So let's deal with the house first. Okay, this is a square root, right? Technically there's a 2 there. So to undo it, I'm going to go ahead and raise it to the power of 2. Therefore, the square and the square root will cancel each other out, giving you x squared plus 4 equals 49. Now, of course, in this particular section, you are solving for x. So I'm looking down here and saying I have x squared plus 4 equals 49. So let's get rid of the 4 for a second. Easy enough. That gives me 45. Now, instinct says, okay, well, here's a square root. So to undo a square root, of course, I would cube root it. So frequently people dive into the cube root and they're going to get x equals the cube root of 49. You may even be bright enough, or maybe bright enough is not the word, but clever enough to say, or however you want to say it, I'll go with clever, I'll stick with clever. Maybe you're clever enough to realize that this does break down a little bit more, and you should always be checking to say, can it break down? Therefore, you get 3 square root of 5, and frequently people say, done, that's my answer. However, I do want to refer you back to this step right here, okay? It's really saying, yeah, sure, we can do the algebraic, method of square rooting it, and that's all fine and dandy, but what it's really saying is what number squared gives you 45. So if I plug in a 3 root 5 and I square it, you'll absolutely get 45, no problem. But what about negative? What if I plugged in a negative 3 root 5? Well, then I would be taking negative 3 root 5 and multiplying by negative 3 root 5 because it's squared, right? Negative times negative would give me positive, and all of a sudden I still get a positive answer. So you really have to be careful and think about those pluses and minuses. And my rule of thumb, me personally, is I always say if I end up, it doesn't matter if I square a house, because the house always comes out as positive. So if I square a house, that's fine. But if I have something being squared, x squared equals 49, that x squared could be positive or could be negative. So whenever I square root a variable, something that wasn't there originally, when I square root something, you need a plus or minus. All these other options over here, this one here, I raised it to the power of 3. I did not put it under a house. It started in a house, but I did not put it in a house. Over here, I square rooted it, or I squared it. I did not put it in a house. It started in the house. All I did was square it. This one over here, this one started in a house. All I did was take it to the 3rd power. I never put anything in a house that wasn't already there. If the house was there in the beginning, that's great. All I did was raise it to a power. This over here, I magically made this house appear. Therefore, I need that plus or minus. Now, that wouldn't apply if it was a cube root, because very similar to what we talked about on the front, in cube roots, it would have to be negative or it would have to be positive in order to get you to your answer. But if it's an even root, you really need to be thinking about those positives and negatives. That's why we put the absolute values on there, because it could be positive or it could be negative. So same thing on the back here. If it's an even, or if you square root it or 4th root it or 6th root it, anytime you even root something, you need to be thinking about those pluses or minuses. Even if you're talking about on the front here, if it's an even index, you need to be thinking about those pluses or minuses. But that wraps up kind of the unit as a whole. I would encourage you, especially my students, a reminder that this practice review does not encompass 100% of everything that we learned. So you still might want to go back over some of your homework assignments or some of your notes and maybe look at a couple more examples. You know, here we foiled one, but it was a conjugate. What if we foiled one that wasn't a conjugate? Are you okay with that? The example down here where I threw in that extra 5, you might want to go back and look at a couple maybe in your quizzes that had ones like this that you could kind of practice with. Definitely a reminder, you have your yellow pieces of paper. You are allowed to put, at least my classes, you are allowed to put anything you want on that yellow piece of paper. So really make it count. And good luck on the radical test. Pun not intended.